Today, let's continue to look at loops in my research spreadsheet environment, Planarly, where we need to access previously evaluated values in the same expression. Say we wish to make a function digits to expand a number into digits like this. We can do it in two steps. First, we divide the input x0 by 10 in each row. Then, we take the mod 10 of each of these numbers to produce the digits. The second step can be easily expressed as a vector operation. So let's now focus on the first. To do the first step in a conventional spreadsheet, we'd drag the formula floor b2 divide by 10 down just before we reach 0. This approach relies on code duplication. Bad. But worse yet, the logic for loop termination is not encoded programmatically, so the sheet accommodates only 4-digit numbers, and there's no way to make it more general. Back to Planarly. To generate this desired column, we use table comprehension, Planarly's answer to loops in conventional programming, inspired by Python's list comprehension. Unlike the examples we saw in the last episode, the cells in this example depend on previous evaluations in the same table comprehension expression. While this is impossible in Python's list comprehension, Planarly does support it with the keyword me. // is the floor division operator, like in Python. Capital R is the loop row counter, and capital C the loop column counter. When neither R nor C appears in a table comprehension expression, Planarly only loops through the R's. Me is a keyword denoting the cell currently being evaluated. The expression me up 1 has a bit of magic built in. At this cell, me up 1 unambiguously moves outside the spill area of the formula being evaluated. Hence, it refers to this actual cell. At this cell, me up 1 refers to a location covered by the current table comprehension expression, so it refers to the just evaluated result at r equals 0. Our expression has a well-specified termination condition, me up 1 being at least 10, which fails here. If we try to refer to a yet-to-be-evaluated cell in the same table comprehension, like me right 1, we'll get an error. Back to the digits problem, the return value. From x0, grow south till a blank cell is encountered, and do modulus 10 on the whole vector. And we have our digits function. We can try it in the main sheet. If we wish to generate a row instead, we can use the column-wise table comprehension. In a column-wise table comprehension expression, when neither R nor C is present, Planarly loops through the columns with increasing values of C. The while condition fails here, at C equals 3, terminating the loop. Correspondingly, we would now grow east from x0 and take mod 10 to produce the digits. Now, we can attempt this medium-level LeetCode problem, add two numbers. We will adapt it slightly to be in table form. You were given two columns representing two non-negative integers. The digits are stored in a column in reverse order, and each of their cells contains a single digit. So 2 above 4 above 3 represents the number 342. 5 above 6 above 4 represents the number 465. Add the two numbers and return their sum in the same format. 7 above 0 above 8 in this case. You may assume the two numbers do not contain any leading zero, except the number 0 itself. Other examples are 0 and 0 should produce 0. 99999 and 9999 should produce 899901. Let's create the add sheet-as function, with inputs x0 being 99999 and x1 being 9999. We can do this problem in 2 steps. First, the incoming carries at each digit. The ones digit has no incoming carry. For the other digits, we'll need to add the 3 entries in the previous row and compare the sum to 10. When r equals 0, we add these 3 cells and floor divide by 10. When r equals 1, we add these 3 cells and floor divide by 10. Now that we have all the incoming carries, we add up the 3 columns and take mod 10. The down till operator grows x0 down till the row of z incoming 2, which is the end of the spill area of incoming 2. The digits region is almost our return value, except that it could have a leading 0. So if we see 0 in the last cell of the digits region, we return the digits region till the cell just above z digits. Otherwise, we return the entire digits region. Let's see the function in action. Yes, yes, yes. LeetCode medium level unlocked. I hope you liked table comprehension in Planarly. Thus far in the video series, we've seen how Planarly adapts many concepts in conventional programming to the context of spreadsheets. Variables become cell labels, arrays and structs become tables, functions become sheets as functions, loops become table comprehensions. Next week, we'll see how C pointers become references in Planarly. Planarly is my passion research project. You can try it live at planarly.com in Chrome. The application is an Affero GPL licensed open source software. It runs entirely in your browser, and your data never leaves your computer. Follow me on Twitter, Dr. Planar, and see you next time.